Hello everyone. Welcome back to Dr. Liu's VCE Physics channel. Today, let's learn together about the 2020 physics examination. We will focus on questions related to the light as a particle. My explanations may not be perfect. If any teachers, parents, or students find errors, please feel free to provide your guidance. If light is considered as a wave, an increase in amplitude should increase the energy of light. If light is a particle, an increase in frequency should increase the energy of light. If wavelength decreases, frequency should increase. So, a decrease in wavelength should increase the energy of light. All of the statements are correct. Work function is directly proportional to cutoff frequency, which is the intercept on the horizontal axial. From highest to lowest, the metals are lithium, sodium, potassium, and nickel. The key word is emission. Emission means that photons jump from the high to low level. The most energy is the largest gap between levels. Jumping from level 2 to level 1 is the largest jumping gap. To form stable energy within atoms, electrons should behave as standing waves. The circle lengths should be the whole number of wavelengths. So, only standing waves at particular wavelengths are allowed. The maximum kinetic energy is in inverse proportion to wavelength. So, B is correct. This is a photoelectric cell. The light shines on the metal surface, and the voltage of the battery can be varied in value and reversed in direction. If the intensity is triple, the current value should be triple. However, the frequency remains the same level, so the stopping voltage is the same as in previous experiments. Point A shows that the photocurrent is 0. So, this point A is stopping voltage. The most common error was to identify it as threshold voltage. In the photoelectric effect, threshold voltage is not a commonly used term. The threshold voltage is directly linked to the threshold frequency, which is the minimum frequency of light required to eject electrons from a specific metal surface. The stopping voltage is sufficient to turn back even the most energetic photoelectrons. So, the photocurrent is 0 at point A. If the relativistic effect is ignored, we calculate the kinetic energy of an electron with the classic physical equation. Please convert the joules into electron volts. Since the diffraction pattern of the X-ray is the same as that of electrons, the wavelength of the X-ray is the same as that of electrons. Using the de Broglie equation, we calculate the wavelength of electrons, which is equal to that of X-ray. Then, we calculate the energy of the X-ray with Planck's equation. Here, the speed of an X-ray is the speed of light. We use the Planck constant in electron volts so that the energy of the X-ray is eV, which is required here. The lowest energy has the longest wavelength, which is 668 nanometers. Using the equation about wavelength and frequency, we calculate the frequency. The units must be converted into IS units. Only certain energies are visible because the electrons exist only in certain discrete energy levels. As the electrons transition between these energy levels, they can emit only discrete amounts of energy. Therefore, only certain wavelengths and energies are present in the helium spectrum. In light as a particle, 5 multiple-choice questions are worth 5 marks, and 3 short-answer questions are worth 14 marks. The overall score for this section is 19 marks. With a total possible score of 130 marks, The percentage for this section is 14.6% of the total score. If you need my help, please add me on WeChat or WhatsApp and send me an email. Thanks for your attention. Please note Dr. Lu's VCE Physics channel, Dr. Lu's VCE Chemistry channel, and Dr. Lu's VCE Biology channel.